In this video, I'm going to show you how to calculate related rates using trigonometry. So here we suppose that an archer shoots an arrow at an angle of elevation of 60 degrees with an initial velocity of 50 meters per second. We want to know how fast is the altitude of the arrow increasing when the arrow is initially shot. Here we've got a triangle representing the situation. We've got our angle of 60 degrees, and why don't we label the altitude, the height of the triangle here, and what we are trying to find is the rate of change of the altitude when the arrow is initially shot, so dA dt. So what is dA dt equal to? That's what we want to find out. But before we get into that, is there any other information in the problem? Well, we're told that the initial velocity is 50 meters per second. So when the arrow is traveling up here, it's traveling at a rate of 50 meters per second. So that means the hypotenuse of this triangle is getting longer at a rate of 50 meters per second. And if we call it c, then that means dc is equal to 50. Okay, so now back to the derivative here. What is dA dt? Well, let's do what we usually do. Let's try to pull that apart into dA over something times something over dt. And since we know what dc dt is, that's a really strong indication that we should be filling in the blanks with dc. So let's go ahead and try that out. So we know dc dt, but what is dA dc? Well, why don't we try to think of a relationship between a and c, so that way we can make an equation and just differentiate. In particular, think trig. What trig function, when applied to 60 degrees in this triangle, relates the opposite side a to the hypotenuse c? Well, that's just sine. So we have that sine of 60 degrees is equal to the ratio opposite a over hypotenuse c. Great, so we've got an equation relating a and c, and now let's just solve for a and then differentiate with respect to c. So first solving for a, multiply both sides by c. So first solving for a, we multiply both sides by c, and we get that a is equal to c times the sine of 60 degrees. And if we differentiate both sides with respect to c, dA over dc, that's just going to be equal to the constant that is multiplying c here, which is sine of 60 degrees. And we can go ahead and simplify that. Sine of 60 degrees is just root 3 over 2. Great, so now we can just go ahead and substitute into this product. 50 will go in for dc dt, and root 3 over 2 will go in for dA dc. And the result is that dA dt is equal to root 3 over 2 times 50, which comes out to 25 root 3. And what's our units on here? Well, this is how fast a is increasing, and a is a length, so units are length meters over time, so meters per second. So there we go. That is how fast the altitude is increasing when the arrow is initially shot. 25 root 3 meters per second. Next up, we have a ladder problem. Here, a 5-foot ladder is leaning against a wall. If you begin pushing the bottom of the ladder towards the wall at the rate of 0.5 feet per second, then how fast is the angle between the ladder and the ground increasing when the bottom of the ladder is 3 feet away from the wall? So here we've got a diagram. The hypotenuse here is the ladder, it's 5 feet long, and it's leaning against a wall. And we want to figure out the rate of change of the angle between the ladder and the ground. So here's the ladder, here's the ground, here's the angle. So we want to figure out what is d theta dt. Alright, well, before we get into this, let's take inventory of whatever other information we might have. We are pushing the bottom of the ladder towards the wall at a rate of 0.5 feet per second. So why don't we label the bottom of the ladder, call it b, and then we can say that dB dt, the rate of change of b, well, b is shrinking at the rate of 0.5 feet per second, so that's equal to negative 0.5. Okay, so now that we've identified the derivative that we're given, let's go ahead and split up this d theta dt into d theta over something times something over dt. And we already know dB dt, so why don't we fill in that something with dB. Now the task reduces to figuring out what is d theta db, and again we can just try to construct a relationship between theta and b, turn that into an equation, and differentiate that. So think, what is the relationship between the angle here, the adjacent side, and the hypotenuse? Well, the trig function that wraps all of that up is cosine. Cosine of the angle, cosine of theta, is equal to the ratio adjacent, which in this case is b, over hypotenuse, which is 5. And now we can just differentiate this equation with respect to b. Derivative of cosine is negative sine, so we've got a negative sine of theta, but then got to chain rule it, got to multiply by d theta db afterwards. And then on the other side, derivative of b over 5 would just be 1/5. So solving for d theta db, we just divide out by that negative sign and we get that d theta db is equal to negative 1/5 sine theta. So there we go. That's what we can stick in for d theta db. Put that in here. And then db dt is negative 0.5. Put that in here. And we have that d theta dt is equal to negative 1/5 sine theta times negative 0.5. And why don't we interpret that negative 0.5 as a fraction to make our life a little bit easier. So this is negative 1/5 sine theta times negative 1/2, which comes out to just 1/10 sine theta. But wait, we're not done yet. We want to find d theta dt at the particular moment when the base of the ladder is 3 feet away from the ground. So how do we find that? What is that equal to? Well, ultimately, we just need to find sine of theta when b equals 3. And then we can just plug that into our formula for d theta dt. So let's think. If b equals 3, then what is sine of theta? Well, sine is opposite over hypotenuse, and we don't know the opposite, but we know 2 of these sides here, so we can figure it out using the Pythagorean theorem. Why don't we just call this side x, and then we'll solve for what it is. So we have that x squared plus the base, which is 3 squared, equals the hypotenuse, which is 5 squared. So x squared plus 9 equals 25, which means x squared equals 16, which means x is the square root of 16, which is 4. So x equals 4, and that means sine of theta at this particular moment is equal to the opposite, 4, over the hypotenuse, 5. So d theta dt at b equals 3 is equal to 1/10 times 4/5, which is equal to 1/8. But let's not forget our units. What are the units of angle? Well, angles are measured in radians, and this is the rate of change of angle over time, so radians per second. So there we go. That's how fast the angle between the ladder and the ground is increasing when the bottom of the ladder is 3 feet away from the wall, 1/8 radian per second. So now we know how to calculate related rates using trigonometry. And in the future, we'll continue learning how to calculate even more kinds of related rates, such as with cones.